Okay, I just wanted to really quickly take a look at this general idea of using targeted displacement maps that are being driven from within Houdini. So this is a very quick test, very rough, lots of rough edges to it that still need to be knocked off, but this is the general idea of how we could construct some dynamic displacement within Houdini. Check it out. So I want to talk real quick about uh, deformation triggered displacement. So there's a lot of discussion points here that we could cover. There's lots of ways to implement this. The most complex being, vellum-based solutions where you can simulate compression and allow the skin to slide over a surface, which is great. It's complicated. It's a lot of setup. So let's start at the very other end of that, which is to start building up something that is very simple. So what is the most simple thing that we can kind of start with? Well, that's taking a tube, right? So this is a very simple, I'm not going to go through every node here, but basically just building, a little UV modeled tube and then doing some deformation. In this case, it's a wire deform, or sorry, that's a wire deform. This one was based off of, first one's off of just using a bend, right? So we're just doing a simple bend, on this little worm guy here to represent what happens when, this could be a finger, this could be a rope, whatever this is. I guess ropes don't wrinkle, but so essentially what we do in the most simplistic is we can go in and we can measure the perimeter length of each primitive, right, or face in this case. And we measure that when it's in its rest position, then we measure it again when it's in its deformed position. And then we can take the difference between those two, that delta, and that can then become our stretch and our compression. So then with this, I just did a little bit of remap for visualization and then went ahead and recolored my geometry based on those, being that red is going to be my compression and green is going to be my stretch. So here we can see that, that plays out very simply. And we've got, as it curls up, we have a compression attribute that's developed, and as it stretches out, we have a stretch attribute. When we come here to the geometry spreadsheet, we can see that, and I believe those have been passed, promoted to the points. And some of the reasons for that was the ability to blur those and make them look as smooth as possible. With that, we can do some very simple things, right? We can, come in and, we can drive some shading attributes based off of that. So, in the shader, this all looks crazy complex. It's not, this is just a bunch of turbulence noise to give me some displacement, to give me some breakup in the color, those kind of things. And then you'll see that we're using the stretch and the compression and bringing those in and doing some multiplication to either color correct or diffuse, which for whatever reason, this is rendering pretty white. I'll show you the final render. But there's a lot of power in this. When we get into, doing a realistic human character, you think about knuckles and faces and how much when we squint, it forces the blood out of the skin, which would change the subsurface quality and the diffuse quality. And there, you could remap some color values as well as your displacement. These are all really kind of powerful pieces. So again, this is nothing too fancy. It's just turbulent noise and then fitting that, which I'm not actually even doing anything, multiplying it down and then multiplying that by the compression. Again, I'm just remapping that a little bit to get a bit better of a distribution than what I got out of the sim. So I can, modify that in the look dev, as you will, to make this work as well as possible. And we went through a couple of different things. We have that, and then I took that same tube and ran that tube through through a different way to animate, right? So instead of just having it bend, if we look at this, now this this tube, this little worm, he's kind of bending through a path, and you'll see that kind of moves and wriggles as he goes. And so we can see that we're getting compression in certain areas and we're getting stretching. Now, this kind of started to push it to its limit. We started to have flicker in some of this because as you're measuring each face, to capture whether it's compressed or stretched, you do run into scenarios where a face could be compressed in one direction and stretched in another, and gives you the same resulting value for that primitive as the rest does. And so while it is being compressed in one axis and stretched in another, you're not getting you're not seeing that. And so that'll cause some flicker and some artifacting at some of these at some of the transition points. And so, you know, as this bends and kind of twists around, it really is at its limit of what is possible with this. I think these are called tension maps. Generating a tension map, really, I can't see it being any, for a human character, being anything really more useful than maybe fingers. I think everything else starts to really need a little bit more dynamic of a system. Okay, so from there we move into a face, right? So in this case, what we started with is Houdini's just template head. And I did a few things in here. I deleted the eyes out. I made some UV modifications to the character to get a result that was actually matching to another character that I'm going to transfer this onto. So that became an important part of kind of my initial setup. And then I wanted to increase some edge geometry in the eye area. So I went through and just manually did that. This is nothing procedural or exciting, just very simple, adding some edge loops. And that became our template head. So I cleaned that up and got that ready. And that head is different than what is the head of like my character. So if I go into my character and look, you know, it's different topology. These are two different things, and I wanted to kind of see how that was going to work. I think ultimately it's better if you have all of your characters using the same topology, and then you can set this up on one character and have it work across all characters because their topology is the same. So essentially, it's really the same thing. So this looks fairly complex, but it's really not. So we bring in our template head geometry in this case. Here we are, right? It's coming in from our initial setup. I probably should have done some of this other setup in that other area, but I kind of made a couple of additional groups to allow me to. I was going to do some additional facial rigging as a test, but kind of put that on hold. So then edit to have closed lips, like my character coming in, and then all of this in here is really just creating some very simple blend shapes, right? So that's all that is, nothing fancy. Just using an edit node. When we do that, going into this tweak mode, and then you can pick whatever it is you need, and WERT allows you to manipulate those, rotate, scale, transform. And then I connected those all into a blend shape node. And with the blend shape node, now if we just kind of drag, we'll see that is going to go ahead, and we can see that gives me some animation that I can start to work with. Now, just like we were doing before, we went through and we measured the perimeter of this. So this is the perimeter of the rest pose, right? So we can see here, this is just a heat map showing the results of that, right? So the smaller faces are going to be blue and the larger faces are going to be red. So there's nothing there that's saying where the tension is. That's just the distribution of those values. So then coming off of our animation of that, we are again doing the same measurement of, I was doing a dual measurement to kind of do some stuff, but we actually don't need that anymore. So we've got our perimeter and area, and then this is just the same math that we were doing before, right? To get, maybe that was necessary, to get our values. And then again, this is just some remap to kind of help push those into a more viewable space. And then at the end, here's essentially my two tension maps, one for compression and one for stretch. So we can see that as they smile, we get stretching in this area, compression in this area. And now we've got this nifty little head animation that's measuring some of that change. Okay, Same idea that we're going to drive some displacement and we're going to drive some color with our tension map. And there you go. So now we can see that the color is being driven, as is the displacement. Now, the reality is where a lot of the idea for this came from was an artist named Chris Jones. So Chris Jones had a great post for back in February 2021 doing this kind of very thing. So this is the results of his work, so which is using 2 different displacement maps, but that then there are lots of masks that get influenced by the blend shapes on the rig, right? So this is all done inside of Blender, I believe, when I read this. And essentially what's happening is, you know, those masks are turning on and off based off of some connection to the rig. Now, if your rig does not live in your same software package or in your shot work, then that becomes a little bit difficult if you're not passing that attribute downstream. So these are the 2 maps that Chris is firing, right? Which we can see that based on expression, right? When our brow knits together, that's one kind of displacement, where when our brow raises, it's different, right? Same with when our corners of our mouths go up, right? It triggers smile lines. And then when those things come down, there's different displacement from the corners of the mouth. So I took these maps because they're great, and I just kind of mushed them around to make them somewhat fit my little template head, just for the purpose of seeing if what I'm doing it actually works. So now if we look at this, one of the problems that we have with this is when we have a smile, it creates compression in this direction. And when we have a frown, it creates compression in this direction. So the question becomes, how do you separate those two? So, you know, you could, I guess, like Chris is doing, use masks and something of the sort to try to get these separate areas, but that it wasn't working very well in this setup. Like his setup is much more articulated. That's not the right word. Much more granular in its approach, right? So each thing kind of is driving and being driven by the artist's input, right? So just like on that blend shape node that I had selected, which gives a bunch of sliders, right? This blend shape node has a bunch of sliders that have keyframes on it. So ideally, this is creating an attribute onto your mesh that then your shader can call, and then you can use a mask to confine it, or, you know, whatever. But it gives you the ability to say, because I wouldn't want this to just be like attributes on the verts. I would want this to be detail attributes, right? So this would be passing a detail attribute that would be sneer. So for example, we could do something like this. We could do attribute create. And what we're going to do is put this on, is this the right node to be using for this? Yes, it is. Detail attribute. And we're going to call this sneer, right? Because I think that's what was engaged right there. It is. I'm going to right click, copy this parameter, and I'm going to come to sneer, and it's going to stay float. The default is 0, but this value, I'm going to say paste relative reference. And then now we have a sneer value that we can see gets set based on what the rig is doing. And then you could have every single one of these blend shapes, right, to be passed through into your detail attribute. So this is the lightest weight to carry that. If you put this on every point, you'd have a lot of just redundant data that is very expensive, and that would not be the ideal. And then just like we were showing before, where we had a bind node within the shader that was pulling in compression, you would have a bind node that is pulling in sneer. And so then you would multiply sneer by a mask that you probably would have painted, or a texture map that you had for that. And then multiply that against whatever displacement the sneer should be driving. And then you would screen that or layer that together, depending on what shader you're using, shading type or render engine. You would merge those displacements together, and so you'd get that sneer based off of that. I wanted to avoid this because in the workflow that I'm working in, it comes in from Maya, and so we didn't want to put that extra into the Alembic. And so this is about, okay, great, how do we go measuring? And again, this is measuring based off of the entirety of, like, each face being measured for its perimeter length. and that gave us a kind of a less than desirable result, right? We got kind of a stack up of the two different maps. It was not easy to isolate because one is not a compression map and one's a stretch map. They are both different forms of compression. So then the next version of this was to take our rest head and to just go through and pick a set of lines that represent kind of the compression that I wanted to track, right? So you see here, kind of I have this, when we smile, these lines are going to compress. When we squint, so this is based off of this map here, like, okay, what would be the areas of compression along a singular vector along the face, or on a singular direction, right? And then this would be the other. And so you can see that's the one, and then and this is the other. And then we're copying those onto our animated geometry because it's the same geo. So we can define it on the one and copy it to the other so they both have that. I'm using a great little tool. You could make one of your own, but this is just from the Houdini Labs. A plug for Houdini Labs is edge group to curve. And so it does a great job of taking those curves that I selected and generating edges out of those, or curves, right? Taking the edges and generating curves. Now we can see that I've got 79 polys selected here, and it makes a single poly line that has multiple points on it, which is not what I want, because if we go to measure this on the primitive, it's going to measure from here to here, which will capture the data that we're talking about, but not with the fidelity of where it's happening that I'm looking for, right? So if we had a little bit of smile, it's going to fire this entire curve versus a magnitude along the curve, right? So in this case, I use a node called convert line, which is great. So if we look at this one, we now see that I have 946 polygons. So between each 2 points, I have a separate primitive that allows me to measure the distance of those. And now this becomes just like we had before. So we measure the perimeter or length again, and then we come into the attribute wrangle and we take the delta between those two, right? And then this is still all the same of just moving that into a space of, the delta change was so small because of the scale of this, I had to scale down that input max. And then this is, again, stretch and delta and compression being promoted. And then we're converting those to a color. So that way we can visualize. Oh, that's actually into a deformer. Here's the color, right? Or maybe not. Somewhere here's a color. I actually don't think I put color on this. The color gets defined in the shader. Then we come and merge these back together, and now I've got these two set of lines for visualization, just for rendering. But for our mesh, which we can see we're outputting here, the way we copy these across is we use an attribute transform, which it works just by basic proximity. So now, based on distance and blend width, I'm able to ray an attribute from the curve onto my face mesh. And so I'm able to capture based off of that and move those across. So now I've got my deform A and deform B, which are my two different compression maps. And then I'm outputting that mesh. And so we'll see that mesh now has the deform A and deform B. Not sure why those ended up as UV attributes. I can't remember. Oh, because I had compression and stretch in each one of those. So I made a vector 2 out of that. Okay, because I didn't know if I was going to use the stretch for something else, which you could down the road, right? The stretch would allow you to reduce displacement on the stretch side and change color and those kind of things. So allowing both of those to kind of come through. So, and then I'm doing a little attribute blur to soften those out so that way it looks a little nicer. So if we were to view this and take a look at deform A, right, and deform B, we can see those compressions happening, right? So there's from the one to the other, right? Just softening out those a little bit so they're not so hard. So that then gives us the beginnings of this, and I went ahead and jumped all the way to wanting to transfer this onto another character, right? So I think I did one version, a render of this head rig using that, but then I wanted to transfer this to my other character. And so we can see here, and again, for an actual animation and rig, this is not sufficient, but just the general idea. So I have my character coming in, putting him in Houdini scale, doing some stuff to get to just the skin, unpacking, and then we're taking this skin, right, and we're freezing it at the original position, and then we're just raying on. What am I raying on here? I'm just sending an attribute here. So what happens is this ray and gets the UVs off of my template head, right? So this was my character. UVs looked like this, which are different than the UVs of the texture map that I created off of Chris Jones's work. And so I just wanted to say, okay, great, I'm just going to steal the UVs off of this other head. I don't need to be perfect, right? So that's why I took this one and kind of moved it into the same place. We blurred the UVs just a little bit, or sorry, that's not blurred. That's a renamed from UV to UV copy. So that way I'm not writing over the original UVs, so I can have a unique set. And then the ray node, if I turn off the transform points, right? So if we see transform, it's taking my character and sucking it onto that head like a wrap deformer. I can turn that off. And now all I'm doing is I'm grabbing the UVs off of that because I'm telling it to import the attributes from the hit, and it's that UV copy. And so that allows us to then use that later for our displacement map. Then I'm using an actual point deform where I'm just taking it, I'm not even lining it up that great. And so here's my head. This is my head at the the rest pose. And so I'm associating the rest pose with my resting character, and then I'm using the deformation to drive it. And it's not perfect. Again, this is just meant to be a test, but this gives me a decent amount of ability to go in and say, great, using the same animation across the two characters. Now, for this, we take the actual lines, and we're now raying on the deform A and deform B attributes. Same thing that we were doing before. We're not actually transforming any points. We're just raying those attributes to capture those. What are we doing in here? So now this is creating a new attribute. So we took this UV copy, which gave me UV copy, I believe, is a 3 vector. It is. And so just for cleanliness, because I think Arnold or whatever I was trying to render this in, not Karma, something else, wanted a UV2. I was testing some other render engine. And so I just moved this to UV2 because it was very specific as to what it wanted. And then we do a little cleanup. We get rid of that UV copy. We're smoothing out these points just a little bit because my yucky deformations made, up with my point deform were less than perfect. And then recalculating the normals. So from that, now we have a character that if we go out to the stage and we jump into our material for this, we'll see that so this is using material X. So that's why I needed that UV2. So using material X, I'm just doing a simple shader. I was using, for a time, I think I turned it off, I did. I was using my deform A, right? I was breaking out those two different attributes, and my deform B to kind of combine those so you could see those in the color channel. I'll show you that in a second. And then here's the displacement as it uses UV2 as the incoming UV set for this particular texture, which is the one that I generated, the two different textures. And then we can see here I'm using deform A and deform B, and each one of those is driving a different texture map as to when it gets multiplied against those. And then I'm adding those together. And then I'm setting my displacement scale. So we come here, not too complex of a setup. So I've got a grid that's for my background. I've got my bringing in my character, applying my materials, some lighting, some render geometry settings, and a camera. And so let's just go ahead and jump in here. And these, I have the character in there twice, so that way we can see it once with, once without displacement. And then we can see the lines that are driving it. So this is just giving me the ability to kind of look at what it was doing. And so we can start to see what this is doing. And this is imperfect. There's some, problems with it, with the implementation of this. But again, this is just a quick, rough test to see, what was possible. This has its challenges. You see here, as we start to raise the eyebrows here, oh, sorry, I went the wrong way. All right, so we have it's triggering here on the forehead, and we can see that we don't really have much triggering down here on the other map. We can see maybe a little bit right there, which is down in here, is triggering. But in some of these, we still get the doubling up of texture maps. They're not all perfect. So here we can see on this one in particular, right? So we have the brow furrowing is triggered, as is some of the brow raising, right? The compression that happens here. So it all depends on that compression of the surface. This is this to me is some of the limitation of this method versus something more of like along the lines of what Chris did, where you each blend shape or rig, deformer is passing an attribute onto the mesh to then tell us what displacement we want to use. And that gives us the ability to fire as many displacement maps as we want and have them, be very targeted. This is a lot more general. And, for the face, I think for a poor man's system, this starts to work okay. So there's, again, some definitely refinement in here and how do you get this onto the an incoming geometry cache, I think is really important. Setting up a delta between a resting deforming face and the deforming face on the actual animation. So there's still some work to be done here. But the general idea is this, and it's not complex. It's just a matter of getting the right pieces, highlighting the right thing. And again, I use the literal edge loops of the geometry. We could go in and draw in very specific edge loops instead, which would probably be more targeted, and I think that would be an improvement. So this is the general idea, a general start to how to go about using some targeted displacement maps within Houdini. And you could drive this for fingers, elbows, knees, all kinds of things. I think the sky's the limit. You just have to build up that system. So hope this helps and that it creates some questions that we could talk about.